Okay, so tonight you're going to learn about fair test and what a fair test is. The reason why we're talking about it is because if you look in your entry document, we have talked about simple machines. We have talked about mechanical energy. We've talked about gravity, friction. Today in class, you talked about magnetism. You've designed and rescued a device to lift a tiger out of a moat. Well, you have designed a device that can rescue a tiger to lift it out of a moat. So now you will test, now you have to test the model. Okay, and so you'll need to decide how to test the model using 3 trials and a fair test to ensure it will work. Well, what does that mean? What does the fair test mean? So that's what we're going to talk about. Okay, so a fair test is an investigation where one factor is changed while all others are kept the same. So what you have your device made, so you're going to pick one factor, one thing about it to change and test it in 2 different ways to see which one's better. So this way the changes are due only to the one thing we want to test. Now, if you were, let's say that you change the pulley and you change the incline plane at the same time, and it changed the results on lifting the tiger out. Well, how would you know if it was the incline plane or the pulley? You can't change 2 things at one time. Okay? So this is an example. If you're testing the effect of amount of light on a growth of a seedling is just a seed. You're going to keep everything else the same, the soil, amount of water, temperature, length of time it grows. You're going to keep all of that the same, and all you're going to do is change the amount of light. That way you know that the only thing that's different is the amount of light. So if the plant grows differently, you will know that it's only because of the light. Because if they all are in different soil, you water them all in different amounts, and they all have different types of light, you'll never know which one actually changed the way the plant grew. So what those things are called are variables. So variables are the things that can change in the experiment. Okay, so in the seedling experiment, the one we were talking about, if you're going to grow a plant, you're going to have a seed. Those seeds have to have soil, water, and sunlight. Okay, so in that experiment, variables were the amount of light, the amount of water, the temperature, and the soil type. There are different types of variables in an investigation. You have the independent variable. That is the thing that you change on purpose. So in your experiment, on the independent variable is going to be what you decide to change and you're actually testing. The dependent variable is the thing that is measured. So what are you measuring? So in that case, they would have been measuring the height of the plant. Okay? And then the controlled variables are all other changeable factors that must be kept the same to ensure the fair test. So the controlled variables in that in the example are the soil, the water, the temperature, all of those things. The only thing that they changed was the amount of light. So the amount of light is your independent variable because that's what you changed. The height that the plant grows is your dependent variable because that's what you measured. Okay? And then the controlled variable is everything else you keep the same. Okay, so let's look at this. How much water flows through a tap at different openings? That's our questioning. A tap is the faucet, basically. So the independent variable, they want to know at different openings so that what they are changing is the tap opening. Is it closed? Is it half open? Is it fully open? Okay. The dependent variable, what they're going to actually measure is the amount of water flowing through the tap. So independent, they're changing the way that the faucet is open, and then they're going to measure how much water comes through. The controlled variables, what they're keeping the same. They're going to use the same faucet. They're going to use the same water pressure. Okay, so those things are going to stay the same, so that the only thing that is affecting the way that the water's coming through is if the tap is closed, half open, or fully open. So here is what you guys are looking at. Which type of magnet will work best to help lift the tiger out of the ravine or out of the moat? Okay. The type of magnet, that's your question, okay? Because you added a magnet today in class. So that's what your question that you're going to try to solve, and what you're going to change in your design is the type of magnet. So the two types of magnets that we're going to be testing are the magnets that come in the kit. So the ones that have the little ends on them that stick together, and then the little circular magnets with the hole in it that I put the need to knows up on the board with sometimes. You're going to test and see which one of those are stronger, so which one would be more effective in your design. Okay, so your independent variable, what you are changing, are the magnets. Okay, your dependent variable, what you're observing, is how much force it takes to pull the magnets apart. All right, and then your control variable is you're going to use the same spring scale to test the amount of force. You're going to use the same design that you already have. You're not going to change that, so you're going to use the same, whatever design you have to lift your tiger, you're going to keep that also. So the independent variable, type of magnet, dependent variable, the force it takes to pull the magnets apart, because the stronger the magnet, the better it's going to be. And then your controlled variable are all the things that you're keeping the same. Your design, the spring scale you're using, all of those things. Okay? One thing you need to remember is when you test this, and you're going to come up with a plan to test it, but when you test it, you're going to need to do 3 trials for each type of magnet, because if you only do one, you don't know if it was just, oh, that just happened. So if you can get the same results or close to the same results 3 times in a row, then you know, okay, I know for sure that this is a true test and a fair test, and that this is the actual results. So what I want you to do tonight is I just want you to, on a piece of paper, I want you to write independent variable, or you can type this on your notes and just show it to me in class tomorrow. But type independent variable, dependent variable, and controlled variable, and I want you to tell me in the magnet design what's the independent variable, what's the dependent variable, and what's the controlled variable, so that we already have those things together when we start doing our investigation or our fair test in class tomorrow. Okay, so you need to come to class knowing what the independent variable is, what the dependent variable is, and what the controlled variables are for your magnet